day everybody. In today's video we'll be talking about differentiation and how to solve them, and particularly we'll be focusing on the quotient rule. Now, what is the quotient rule saying? The quotient rule is saying that when we have a function dividing, when we have two functions dividing u over v, and we want to find the derivative dy dx, is going to be the function here, that is the second function, multiplied by the derivative of the up function or the first function minus the second function multiplied by the derivative of the second function divided by v squared. You notice that it's the denominator that is squared here, and it's the one that comes first. So when we have a function y is equal to x squared over, let's say, sine x, and you are asked to find the derivative, what will be your answer? Here, dy dx is going to be what? The second function, right? Derivative of the first function, derivative of s squared is 2s, right? Yes. Minus the first function, derivative of this one, which will be what? Cos s, all over sine x squared, if you apply the formula very well. Alright, so let's factorize here. S is common there. We have x into brackets 2 sine s minus s cos s all over sine square x. So this will be the final answer. Now go ahead and try this one. Y is equal to s squared over ln x. Feel free to pause the video and try this one. Alright, so the same way we did the previous one, by the same token, we are still going to do it this one. So dy ds is going to be the function that is in the denominator, that will be the what? First function, or the second function rather. Derivative of this one is still 2x minus the numerator function, which is the first function now. Derivative of ln x is 1 over x. That is the standard. All over ln x squared. Alright? You notice that this will cancel 1 from here, right? So we are now having what? We are now having ln x 2x ln x minus a single x all over ln x squared. When we factorize here, we are going to have x is common into brackets 2 ln x minus 1, right? All over ln x squared. So this will be the final answer. I believe you understand how to use the quotient rule to solve question now. Alright, so let's say you are given a rational function like this. Y is equal to s squared plus 3 all over 4x minus 1. Alright, go ahead and pause the video and give it a shot. Alright, first thing first, you have to know that this is your denominator and this is your numerator. Like we said, dy dx is going to be the second function, which is 4x minus 1. You group it as a single function. Then derivative of the first function is going to be what? 2x plus a 0. So we won't write that 0. Minus the first function, which is s squared plus 3 multiply by derivative of the second function, which is 4, all over 4x minus 1 squared. Now we have to expand this bracket, and let's expand it somewhere. Let's expand it somewhere here. 4x minus 1 multiply by 4x minus 1. 4 times 4 is 16. S times s is s squared. 4 times minus 1 is minus 4 times s is x. Then minus 1 times 4s is minus 4x. Minus 1 times minus 1 is positive 1. So we're going to have 16x squared minus 8x plus 1. So that is the expansion for this. So we're going to just open the brackets using the coefficients here. And we're going to have 2x squared, 2x into bracket, 2x into bracket, 4x minus 1 minus 4 into bracket, s squared plus 3 all over this, which is what, 16x squared minus 8x plus 1. So should we further expand? Should we? Yes, but most often than not, it is better you leave it this way, but it's also good if you can expand further, so it shows that you understand what you are doing. So let's expand this. We're going to have 8x squared minus 2x minus 4x squared minus 12 all over 16x squared minus 8x plus 1. So this will give us 4x squared, because this minus this will go, minus 2x minus 12 all over 16x squared minus 8x plus 1. So these are two quadratic functions, and this will be the final answer. Alright, what if you are given a function like this? Are you going to use the product rule, or you are going to use the quotient rule? You should use the quotient rule, because if you are to use the product rule, this negative exponent here is going to cause a lot of trouble along the way. So from indices, we know that anything raised to the power of minus 1 is 1 over a. So by the same token, we can say that y is equal to x multiplied by 1 all over x plus 2. So this gives us y is equal to x all over x plus 2. So now we can use the quotient rule. Dy dx is equal to the second function, x plus 2. Derivative of the first function is just 1 minus the first function, x. Derivative of the second function is also 1 all over x plus 2 squared. So in one of my videos, I will be teaching us how to use binomial expansion. What if it's not 2? What if it's 200? What if it's... So we're going to be talking about binomial expansion. You shouldn't miss that video. So when we do this, we're going to have x plus 2. We're going to have x plus 2 minus x, right? All over x plus 2 squared should be, let's expand it. Let's not just assume x plus 2. X plus 2. This will give us s squared plus 2x plus 2x plus 4. So this will give us s squared plus 4x plus 4. You know, this and this will cancel out, right? So we're now left with 2 all over x squared plus 4x plus 4. So this will be the final answer. I believe you understand how to make use of the quotient rule to solve problem now. If you still don't understand, don't hesitate to enroll into our classes. Link will be in the description of this video. So classes is actively going on every single time. So it's never too late to enroll for our classes, and you'll be tutored by our personal tutors at Mathmech Academy. See you in the next video. Goodbye.